Hi everyone, welcome to this tutorial session. In today's session, we want to look at these two inequalities. This first one, 2x minus 1 all over x plus 2 less than negative 1. And then the second, which is the absolute value of 2x minus 4 less than x plus 1. So we want to get the solution sets of these two inequalities. Let us start. Now, our first inequality says we have 2x minus 1 all over x plus 2 less than negative 1 to solve for the values of x. Okay, we want to get a set of solutions for these inequalities. If we look at the left hand side, it's a rational expression. We should avoid that error to say that we carry out cross multiplication. This is not equality. If this were equal sign, then cross multiplication would make sense. Here, cross multiplication will not make sense because we don't know the sign of this expression down here because of the variable x. Since we don't know the sign of this expression down here, we can't carry out cross multiplication. Remember the laws of inequality say if A is less than B, and then we multiply both sides by negative sign, this inequality sign has to reverse. If we multiply here by negative sign, this inequality sign has to become greater than. Also multiply here by negative sign. So we don't know the sign of this expression at the denominator. We can't carry out cross multiplication. What then do we have to do? We just have to take the negative one from the right hand side to the left hand side. So we have 2x minus 1 all over x plus 2. This negative 1 coming this way become plus 1 less than 0. We have here this expression, so let's put it under the same denominator. This one, we can put this as 1 all over 1, so that our LCM is x plus 2. X plus 2 divided by itself is 1. Multiply to the numerator there, we have 2x minus 1. X plus 2 divided by 1 is x plus 2. Multiply to 1 is x plus 2 less than 0. We have 2x here plus x. We have 3x. Negative 1 plus 2, positive 1. All over x plus 2 less than 0. At this point, we have to look for what we call critical points. Our critical points will be points obtained by setting this numerator to 0 and solving. If we do that, we have x is equal to negative 1/3. Negative 1/3 is a critical point. We also set the denominator to 0 and solve. When we do that, we have x is equal to negative 2. So we have two critical points, negative 1/3 and negative 2. We'll now work using the number line. We test zones. We place these numbers at their positions on the number line. Negative 2 is smaller than negative 1/3, so it's to the left. And then here we can put negative 1/3. We have 1, 2, 3 zones to test. Take a value in this zone. For example, negative 3. Negative 3 is here in this zone. And we put in our expression. This is our expression. And we check the resultant sign. What we are interested in is the sign, the resultant sign. If we take negative 3 and put there, we have 3 into negative 3 plus 1 all over negative 3 plus 2. This gives us negative 9 plus 1 all over negative 1. So we end up having negative 8 all over negative 1. So our final sign is positive. We're interested only in the final sign. So that zone gives us positive results when we slot any value in this our rational expression on the left hand side. Now take the next zone between negative 2 and negative 1/3. A good example of a value there could be negative 1. So if we take negative 1 and put here, let's let's analyze 3 into negative 1 plus 1 all over negative 1 plus 2. Again, we're interested only in the signs. This is going to give us negative 4 plus 1 all over negative 1 plus 2 is positive 1. So we're going to have negative 3 all over positive 1, so it is negative. So here we have negative. Let's take a value this way. A good value could be 0. 0 is always to the right of negative 1/3. Alright, let's put 0 there. We have 3 into 0 plus 1 all over 0 plus 2. This is going to give us a half, which is positive. So here we have positive. Now, which of these three zones, 1, 2, 3, will be a valid zone for our solutions? Okay, so we look here, we have less than 0. Remember, less than 0 means negative. Values here are less than 0, values here are greater than 0. So less than 0 in other words means negative value. So we have negative solution here. So this zone here will give us our solution set for this rational inequality. And so we now say our solution set will be all real values such that negative 2 strictly less than x strictly less than negative 1/3. This gives us our solution set for the first inequality. Our second inequality says absolute value 2x minus 4 is less than x plus 1. We want to get the solution set for this inequality. Okay, the first thing is to remove this absolute sign, and we know the definition of the absolute sign for any function. This expression here can be written as 2x minus 4, all of this squared, square root, because absolute sign of x means x squared square root, less than x plus 1. Now, to remove this square root, we have to square both sides. We square this side, we square that side. The square will cancel the square root. We have 2x minus 4 squared less than x plus 1 squared. That's what we obtain here. Now, we either open this parenthesis and open that other one, or we use difference of squares identity. Okay, so let's open this. We have, this is 2x minus 4 into 2x minus 4 less than x plus 1 into x plus 1. That's the meaning of squaring. Now, when we do that, let's write it up here again. Now, let's open it out. So we have 2x multiplied to 2x. That gives us 4x squared. 2x multiplied to negative 4. That gives us negative 8x. Negative 4 multiplied to 2x. That gives us negative 8x. Negative 4 multiplied to negative 4. That gives us positive 16. Less than. We'll open this other parenthesis as well. X multiplied to x is x squared. X multiplied to 1 is x. 1 multiplied to x is x. 1 multiplied to 1 is 1. Okay, so we have 4x squared minus 8x is minus 16x. So we have 4x squared minus 16x plus 16 less than, we have x squared. X plus x is 2x plus 1. This is what we have. So let's bring everything to the left hand side, and so that we can have 0 on the right hand side. So we'll take this x squared this way. We'll have 4x squared minus x squared minus 16x. We take this 2x this way, it becomes minus 2x plus 16. We take this 1 this way, it becomes minus 1. Then now we have less than 0. So this one we get less than 0. So we have 4x squared minus x squared. It's going to be 3x squared. Negative 16x minus 2x is negative 18x. 16 minus 1 is 15, less than 0. So we end up with this quadratic inequality. It can be simplified because we see 3 can divide all through. We divide each term by 3. Let's divide each term by 3. We're going to obtain x squared minus 6x plus 5 less than 0. Now what we have to do here is to factorize this left hand side. What are the factors of 5? That will give us negative 6. So we have negative 1 and negative 5. So this factorizes into x minus 1, x minus 5 less than 0. So from there we'll get our critical points. Critical points. Points we are going to use in our analysis to get our solution set. Critical point, we set this one to 0. So we'll get our first critical point. We'll also set this one to 0 to get our second critical point. So we'll have critical points 1 and 5. Let's carry out our analysis now. We use the number line again and we'll put the values. 1 is less than 5, so 1 is to the left. So we have 1, 2, 3 zones to analyze. We take a value from this zone and we're going to put in our expression. Our expression is x minus 1, x minus 5 less than 0. Take a value from this zone. A good example could be 0. 0 is to the left of positive 1. And we'll put there, we'll have 0 minus 1 into 0 minus 5. This gives us minus 1 minus 5. Minus times minus positive. So there we'll have positive. The value this way will render this left-hand expression positive. Take a value here. A good example could be 2. The value 2, I will put there to analyze. So we have 2 minus 1 into 2 minus 5. This gives us positive 1 into negative 3. Positive multiplied to negative, negative. Take a value this way. A good example could be 7. 7 minus 1 into 7 minus 5. We have positive 6 into positive 2. Positive, positive, positive. Okay, we have done our analysis. So now, which of these 3 zones, 1, 2, 3, will give us our solution set? Remember, we're talking about less than 0, and less than 0 means negative. Again, here we have our solution. This is where we have negative. So all values in this zone will give us the solution set for the absolute value inequality that we had, this one. And so our solution set will be all real values such that 1 less than x less than 5. This gives us the solution set of our second inequality.